Hello everyone. Today we're going to go ahead and learn how to graph sine and cosine functions. So let's go ahead and begin with this quick warm-up. I want you to go ahead and find me the sine of 240 degrees. So 240 degrees, go ahead and find that sine. Okay, so by now you should have seen that this right here is going to go in our little unit circles. We go ahead and graph our angles, 270 and 360. Awesome. From here, it looks pretty easy on where we can go ahead and see that 240 exists. It goes ahead and exists in between in quadrant 3, right? Right between 180 and 270. So we have something right here that we're going to call 240 degrees. Okay, so you're probably thinking, okay, now that I see this, I can go ahead and find out what the central angle is. So this angle theta right here. So if we don't know it from the straight of our minds, we can go ahead and do a little bit of subtraction. So 240 minus 180 gives us 60 degrees. So this right here will be a 60-degree angle. Now, what I told you guys before in the previous lesson is that this right here can go ahead and be filled in as a 30, 60, 90. So if this is 60 degrees, this right here is 90, and this right here must be 30. So I can easily fill in the blanks. The length projected by the angle 60 is a square root of 3. However, it is below the x-axis, so it is negative. 30 degrees projects 1, which it is also negative because it is on the left-hand side of 0. And 90 degrees will have a 2. Okay, if you're unfamiliar with this, please refer back to the other lesson where we go ahead and talk about the 30, 60, 90 triangle. Okay, so from sine, we know that sine is opposite, right? Is opposite over the hypotenuse. So we can go ahead and see that sine of 240 degrees is going to give us the opposite side of this theta, which is negative square root of 3 divided by my hypotenuse, which we can see is 2. Okay, so that's pretty much how we find these values. So now we're going to go ahead and learn about how to graph sine and cosine. Okay, so we're going to be basing this entire lesson off some critical points of the unit circle. Okay, oops. Okay, looking at the week at a glance for my students that are learning with me live, here is this. Okay, alrighty. So what I want you to do first is go ahead and write this down right here, connecting unit circles with trig functions. What I want you to know is that this value x, I'm going to go ahead and ask you to think about it as a cosine, or as you guys have seen it in physics, a horizontal movement. And sine, I want you to think about that being a height, right? A vertical, okay, movement. Okay, so from here, we're going to go ahead and fill in these little unit circles. So this right here is 0 degrees. This right here is 90 degrees, or pi over 2. This right here will be my pi. This right here will be 3 pi over 2. And I can go ahead and fill in these points. So keep in mind, this is the origin. This is 0, 0. So therefore, this must be 1, comma 0, right? And if I go up from the origin, I get to see that my horizontal did not change, but my vertical did. So this is 0, 1. This right here will be negative 1 and 0. And this at the bottom will be 0, negative 1. Okay, so take a couple seconds to write this down. Pause the video if you need more time. Okay, so you're probably thinking, okay, now that I know that, what's going to happen? Well, we're going to go ahead and use those values and graph sine. So let me go ahead and hide my video panel and my settings here so I have more space. Okay, so the advantage for you is that you already have this written down, but I do not, so I'm going to go ahead and fill it in one more time. So this right here, we said this was 0 degrees, or the point 1, comma 0. This point right here is 0, 1, and it is with association to pi over 2. Pi gave me negative 1 and 0, and 3 pi over 2, right? 3 pi over 2, which is 270 degrees, gave me a coordinate of 0, negative 1. Okay, so for this one, sine, go ahead and write this down. Sine is associated to my y's, my y coordinates, and let me go ahead and highlight them. my y coordinates at every single point. So at 360, it is 0. At 90, it is 1. At pi, it is 0. And at 3 pi over 2, it is -1. And then at a full revolution, it is 0. Okay. So that's what we're going to go ahead and do. Oops. So let's go ahead and begin by, I keep missing. Okay, so let's go ahead and begin by sketching this out. So this right here, this will be my radians, okay, which are my inputs. These are my inputs. My outputs will be my values of y, okay? So you're pretty much evaluating sine of 0, whatever that gives you is the value. So sine of 0, we get to see it. Sine of 0 gave me 0. Sine of 90 degrees gave me 1. Sine of pi, the y value is 0. Sine of 3 pi over 2, right? My y value is -1. At 2 pi, I'm back at 0, right? So y value is 0. And it will always be the same as this one. Okay, now I want to go ahead and ask you guys about -pi over 2. So I'm not trying to mess you up here, but this is something I want you to consider. At -90, which is right here, -pi over 2, the same thing as 3 pi over 4 or 2, I'm back at -1, and -pi is 0. Sorry, I got confused a little. Okay, awesome. So you're probably thinking, okay, cool. Now that I was able to evaluate this, evaluating sine at each one of these radians, what do I do? Well, all you have to do is plot these points. So this is telling me that the first point is going to be 0, 0. The next one at pi over 2, it's going to be at 1, and so forth. Pi will be at 0, and so forth. So 0, 0 right here. Then pi over 2 has a height of 1, right, based off this right here. Pi has 0. 3 pi over 2, we can see that it is a -1, so -1 in height, and 2 pi, sorry, we back at 0. Okay, now I want you to go ahead and think and look at this information right here. We were able to find out the negative versions of these radians by going in the clockwise direction of the unit circle. So I want you to think, is this, let me go ahead and connect the dots, is this the only part of sine? Is this the entire graph of sine right here? So I want you to think about that. This right here, from 0 to 2 pi, given that I showed you these two values. Hopefully you're saying no, because as you can see, as the same way we went in the negative direction, we can go multiple times in the positive direction. So it's important to know that this graph, I'm going to go ahead and highlight this here, these arrows, tell you that this domain for this graph goes to positive infinity and negative infinity. So domain will be from negative infinity all the way to positive infinity. For the reason of the unit circle, you can go many times around the unit circle. You go 360, 270, and so forth, or negative. Okay, how about range? How low can you go? Well, the lowest I can go, because we are in a unit circle, is -1, sorry. And the highest I can go, keep in mind the radius of the unit circle is 1, so will also be 1. Okay, so -1 and 1. Very, very important, especially when you're trying to find your inverses of these. Alrighty, here's my nice little graph. Okay, let's go ahead and try the next one. So go ahead and pause the video and give this a try while I fill in these little circles, critical points, sorry. Pi over 2, pi, 3 pi over 2, and then 2 pi, right? So after a while, you just have these known, but these is just your basic algebra skills that's telling you these coordinates. So cosine is going to be my x values. Okay, so I'm going to go and highlight them to make it easier on me. So I got 1 at 0, pi over 2 gave me 0, pi gave me -1, 3 pi over 2 has a 0 for the x value, and then 2 pi gave me that same 1. Okay, so let's go ahead and plot these points. So at 0 radians, right, at 0 radians, cosine of 0 gave me 1. At pi over 2, cosine of pi over 2, my x value was 0. At pi, I got -1, right? I'm just basing it off at x value. And then 0 once more, and then 2 pi gave me 1. Now keep in mind, we can also check this for negative angles, so -2 pi over 2 and negative pi. We can see that it's going to go 0, and for pi, negative pi, sorry, it gave me -1. Okay. So let's plot those points and go ahead and do it in green. So when the radians are 0, my height is max at its max height of 1. Then at pi over 2, I'm back at 0. And then at -1, I'm sorry, at pi, I'm at -1. At pi 3 pi over 2, I am back at 0. 2 pi, I'm back at 1. So I can go ahead and trace this out. Keep in mind, it's going to follow the same pattern. And hopefully you're not drawing thunderbolts like me. These should be nice curved lines. And make sure you're drawing your angles, your arrows like so your teachers know that these are continuous. You just drew one cycle, if you will. Okay, so let's go ahead and find the domain. So go ahead and let me know what the domain is. And hopefully you were able to see that it's all the real numbers, negative and positive, because of the reason we can go multiple times around the unit circle. Okay, and then the range tells us that the lowest I can go, right? The lowest I can go is -1, and the most I can go is 1. Okay, so far so good. Okay. Now I want to go ahead and talk about something that you will come across, especially when you are working with word problems, and that is the term amplitude and period. So here I have two graphs. One of them is sine, one of them is cosine. So go ahead and identify which one is sine and which one is cosine. So hopefully you were able to say that the top one is sine and the bottom one is cosine. So you in your notebook can see these differences. Sine, y equals sine of x, is this one, and y equals cosine of x is the green one. Okay. Now, very important that the most obvious difference here is that sine passed through the origin when the radian was 0 or 0 degrees. And for my cosine, when it passed through that same radian of 0, my output was 1. So look very, very careful of that too. Now, you're probably thinking, well, I see more similarities or differences, but they look like they're following the same type of curve, right? Well, actually, they are. You can actually shift them horizontally, and they will land on each other. So don't believe me? Well, let's go ahead and do it for sine. So let's go ahead and get this point, and let's shift it a distance of pi over 2. So now it will be over here, right? And if I do that for all my points, right? Every single one of my points, I can see that now they're passing through these points right here. And if you compare it to the green graph in below, you can totally see where, oh snap, they do land right on top of each other. So keep that in mind, okay? So let's go ahead and define what amplitude is. Amplitude, and hopefully you're able to see this with me. If I was to draw a line right here, y equals 0, hopefully you're able to see that I split the graph completely in half, right? This area, well, this area right here is the same amount of area right here. Okay, so the amplitude is talking about the distance, and I'm going to go ahead and call this right here, this line that was used to split them, this midline, the distance between the midline to the maximum or the minimum, the distance between the midline to its max or min. So for the parent function, it is 1. Okay, so it doesn't matter if it's below, it's still the distance is still 1. If you took your pencil to measure here, you can go ahead and say the distance is 1. Okay, the next thing that I have is for cosine, and I can see that the midline is still right there at y equals 0 because there was no vertical transformations or compressions. And we can see that the area itself, right? The area is still the same for these two. So once you get a calculus, you can actually evaluate what this area is. Okay. Next, the next thing I want to go ahead and do is talk about period. Now, period refers to how long it takes for this function to repeat itself. So I challenge you guys to do this in your notebook and try plotting this graph even more than 2 pi. So multiple rotations, and you're going to go ahead and see that right here is the point where the function tends to repeat itself. And hopefully you're able to see that because in the unit circle, after you do a certain amount of revolutions, well, one revolution, you're going to go ahead and see that you're going to be able to repeat. Given that you may have horizontal compressions, or you might actually have these numbers being different. Okay, so from here we have all of this right here. So my period is 2 pi, which makes sense because we did a whole revolution to get these points. Keep in mind that won't always be the case, especially if I have a compression. So if you have a compression, which I'll talk about, you can go ahead and divide that and multiply it in this form to find it. Okay, and we'll do some examples right now. So for both of these, our period was 2 pi because these were the parent functions. Okay, so as I mentioned, the transformations that they have is just of 2 pi over 2. Okay, go ahead and take a second to write this down. We will be talking about our transformations as well. So keep in mind in precalculus, this does not go in. As a matter of fact, every one of our units is talking about transformations. Okay, so it's best if we try to learn them now, right? But keep in mind, I do have videos that talk about this. If not, your Algebra 2 notes should help you out as well. Okay, so let's go ahead and identify the transformation. So a number on the top right here is referring to a vertical stretch by 2. Meaning, instead of me being right at the max of 1, now I have a max of 2. But the idea is the same. So let me go ahead and pause. Let me go ahead and do these right here, these coordinates. So 1, 0. This right here is okay. All right, so we're gonna go ahead and do that. I don't see any compressions here or stretches, so I'm gonna go ahead and keep these numbers the same. 3 pi over 2 and 2 pi. And for funsies, we're gonna do negative pi over 2, right? All right, so keep in mind that it's better if you already have a gridded notebook for this scenario, okay? And this right here is 0. So we're looking at the y values of each of these coordinates, so hopefully now it's a lot easier. For sine, we start at 0, 0, right? We start right at the midline. Then instead of going to my max of 1, I go ahead and get this y value, right? The y values. And this is telling me vertical stretch by 2. So meaning every one of my y's will get multiplied by 2 to give me my new y. So in this case, we have the following. So pi over 2 gives me this right here of 2. If I go to pi, I get 0. And then I'm using these right here. So I'm using this 0 times 2, this negative 1, right? This negative 1 times 2 gave me negative 2 at 3 pi over 2 and 2 pi right here. Okay. I accidentally forgot to do negative pi over 2. So negative pi over 2 is the same thing as saying 3 pi over 2, but it still gave me negative 1. So negative 1 times 2 gives me this negative 2. So we can see right here, and I'll do it in a purple, how the graph is behaving. So hopefully you're able to see that, hey, for my parent function, if you knew that already, you can have just stretched it instead of doing all the extra work I did. But since we're just seeing it for the first time right here, this is a nice approach. But once you know the parent function, you could definitely skip a lot of these steps right here. Okay, so similarly, we're going to go ahead and see that the midline is still the same, y equals 0. My domain did not change, still negative infinity to infinity. My range did change. Now the lowest I can go is negative 2, and the highest I can go is 2. And we can see it off these maxes and these minimums. Keep in mind, I do want you to show these arrows right here because this graph does not stop here. It continues all the way around. the unit circle. Okay, so go ahead and pause this video and give this one a try. So we have this right here. I don't know why I blank out at 3 pi over 2. Okay, so let's identify these transformations. This right here, guys, a negative in front of our function. Remember, it is a reflection about the x-axis. Same thing as multiplying by -1, and this right here is addition of 1, right? So 1 up. So whatever these x values are, right? X values are, you're going to go ahead and multiply by -1 and add 1. So let's do that. I can go ahead and scope these little x values here, right? Hopefully by now you are trying to see the shape that they have. So at 0, right? At 0 degrees, 0 radians, I have a 1. So this is going to be my 0 rad, right? It's going to be 1 times the -1 plus 1. That will be my y value. That will be my output to this input of 1 from 0 rad, okay? So in this case, it's -1 plus 1, which is 0. So that's odd, right? Because normally we're thinking about sine, and it's right here, right? Oh, this right here is pi over 2, my coordinates, because I did not have anything messing with my period. So this right here is pi, this right here is 3 pi over 2, and this right here is 2 pi. Okay. Oh, and don't forget negative pi over 2. Okay. So at pi over 2, positive pi over 2, my x value, we can see is 0. So 0, don't forget that it's going through these transformations. So times a -1 and plus 1. So this right here is just going to be 1. 0 times -1 plus 1 is 1. So at pi over 2, I'm at a height of 1, which is weird, right? It's a little weird. Then we can go ahead and see that we have pi. Pi gave me a value of -1 times my transformation, which tells me -1 plus 1, this one right here. So I have 1 plus 1, which gave me a value of 2. Okay, so that's pretty much what we're doing. We can see the next one, 3 pi over 2. 3 pi over 2 gave me an x value of 0 times my -1 plus 1. That is a height of 1. Last but not least, we have 2 pi, which gave me 1. Don't forget to multiply by your transformations. So we had -1 plus 1, which gave me 0. So pretty cool. And let's not forget negative pi over 2 behaves like 3 pi over 2, like so. So therefore, we get to see that it's going to be 0. So I could probably do here, negative pi over 2 gave me 0 times -1 plus 1 gave me my 1. So all I have to do from here is sketch this out, and I'll do it in purple. So we have this shape going like so. Okay, like so. Okay, so ideally this is still the same idea. Keep in mind the only thing that changed was our, sorry, this should have went up. Okay, the only thing that changed was the transformation. So instead of going upwards like it normally does, it went downwards because of the negative reflection. Okay, alrighty. So the last one, but not least, is this one right here, the 4 pi. So the idea is still the same, but now we have a horizontal compression. Keep in mind, all that's going to happen to our values, which we normally had, which were 0, pi over 2, pi, and 3 pi over 2. All that's going to happen is that they're each going to go ahead and be divided by 4. So this one divided by 4 gave me 0, so that did not change. My pi over 2 gets divided by 4, and that is now pi over 8. If you're struggling with division of fractions, I did make a video about that as well. And the next one is pi divided by 4 is pi over 4. 3 pi over 2, that's a little tough one. I'm going to have to write that out. Divided by 4. Let's go ahead and multiply the denominators here. And I get 3 pi over 6, which reduces to pi over 2. Okay, and last but not least, 2 pi, if I divide that by 4, because the compression told me to, I get a pi over 2. What did I do? Okay. Sorry, this should have been 8. 3 pi over 8, sorry. Here's where I messed up. So this 3 pi over 8 should have been right here. 3 pi over 8. Sorry about that. So therefore, this one is correct, pi over 2. So those are the numbers that will replace these originals. So let's go ahead and write them. Pi over 8. Then we have pi over 4. Then 3 pi over 8. And pi over 2. So notice how if we were to continue doing this all the way to my 2 pi, we would have way more curves inside there, meaning way more periods. So our period in this case will be from 0 to all the way to pi over 2. So notice how the period changed from it being from 0 to 2 pi. It definitely did a lot of change. From here, I'm going to go based off my parent function, which told me sine starts at the center, right? Starts at the center, and then it goes up to a max of 1, then back down to the middle, then to the -1 to its lowest point, and back to the middle. Similarly, I can follow the same pattern and see where it goes at negative pi over 8. So if I trace this, I can go ahead and show you the entire curve. So hopefully they don't look like thunderbolts like mine. But ideally, this is how this version will look like. Okay. Awesome. Okay. So this concludes my video. We saw vertical compressions, horizontal compressions. Keep in mind, most of the times you will see 2 of these encounters, but hopefully this is the basis for what you will be seeing. Okay. If you do have questions, please reach out to me. The homework is these right here. Not that bad. Some basic parent functions and then some transformations as well. Okay. Hopefully this helps, and as always, it's been good. Thank you. Till next time.